Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by Linode, our cloud server of choice. It is so easy to get started with Linode. Servers start at just $5 a month. We host Changelog on Linode cloud servers and we love it. We get great 24/7 support, Zeus-like powers with native SSDs, a super fast 40 gigabit per second network, and incredibly fast CPUs for processing. And we trust Linode because they keep it fast, they keep it simple. Check them out at linode.com/changelog. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Go for Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello and welcome to Go Time, the show where a diverse panel and special guests discuss all things Go is known for, including cloud infrastructure, distributed systems, microservices, and especially today, serverless. My name is Johnny Borsico, and joining me today is a stellar cast of characters, as Matt Ryer usually puts it, including Matt Ryer himself. Say hello, Matt.
Hello.
Making her triumphant return to our panel is Jaana B. Dogan, aka JBD. How have you been, Jaana?
Yeah, good. How are you?
Doing well, doing well. I hope you're ready for this, because this is going to be good. Last, but certainly not least, is our special guest and serverless connoisseur, Stevenson Jean-Pierre. Ça passe, Stevenson?
Not boule. How are you?
Good. For those of you paying close attention, Stevenson and I are both originally from Haiti. So that's that little, ça passe, not boule thing right there. Yeah, so today's show is a special one. It's kind of near and dear to my heart because I am a fan of using what has become known as serverless technologies. We'll get into what really that means and why we call it serverless, although that's more of a marketing term, but we're going to get into that. So let's start with some ground setting, right? What is serverless technology? What did that term come from? What is it really trying to sort of relay? We know it's a marketing term, but what is really sort of the intent, right? When you're using serverless technologies, why would you sort of reach out for it? What is it? Like, let's do some ground setting here.
So from my point of view, it's just about not having to worry about the deployment too much. So I use Google App Engine a lot, the standard environment. And I like that. In fact, that was the reason I first got into Go in the first place, because to use it, you had to either write Java or you had to write Python. And I didn't know either of those. And there was this other little language, it just said Go with a little experimental badge on it. And I'm like a magpie to that kind of stuff. I was very interested. And that's why I first discovered Go. And the promise of App Engine is you write your Go code and you give that code to Google, and then they will make sure they can run it when it's needed. And that, as a developer, is nice because it was never an area for me that I was particularly interested or particularly well skilled at. So it was nice, at least the promise is nice for me from a developer's point of view.
For me, serverless is a combination of two things. So for me, it's a lot of event-driven work. So I consider it serverless when it's driven by an action being taken as opposed to constantly just being up and waiting for some kind of request to come in. But then with that's the compute side. But then you have like even serverless technologies coming out on data storage, right? Like things like RDS serverless or Aurora serverless. So you can have compute, and it goes to Matt's definition there, where you don't have to worry about the underlying engine. You don't have to worry about configuration. It's just there and ready to kind of scale when you need it to be.
For me, it's kind of like, I think it's similar to what Matt is saying. It's more of like, I don't have to deal with infrastructure that much. It's more of like an abstract layer on top. And like some of the things are considered just taken care, of on behalf of me. And I think what is the other important aspect is like it's more of like a pay-as-you-go model. So you don't use it scales down to zero, you pay as you go. That's what the definition of cloud should be, to be honest. But this is a really tough topic because I think serverless became just kind of this like umbrella term, and it I think means more abstract things. But like everybody's, there's so many different layers of abstractions, and everybody is each higher level is actually more serverless than the lower layer levels. So that's why I think it's good to say that like the less you care about infrastructure, operating and maintaining the infrastructure and pay as you go, and if it scales down to zero, that's serverless to me.
So the common thread here is basically not having to worry about managing the infrastructure that is running your functionality, right? That's the, be it compute, be it storage, be it sort of some sort of integration with basically the event sourcing thing, for example, like in the case of AWS, where they have different things that can trigger functions and whatnot. You don't have to, you as the developer, don't have to worry about sort of the plumbing, the underlying infrastructure. You don't have to provision instances. You don't have to, you don't have to do any of that stuff yourself. Basically, you kind of really sort of stitching together or linking together like different Lego blocks that do certain things, that react to certain things whenever they happen with your environment.
Yeah, I think like the promise is just care about the business logic, and we will take care of everything yourself. And these are like the fundamental blocks you can use.
So when I first started to get into the quote unquote serverless, and that term means different things to different people. There's even a framework called serverless, and that's really not what we're talking about here. We're talking about sort of the concept, right? No one technology or no one framework, no one product. When I first started sort of exploring it, I kept seeing these use cases around upload an image to S3 and then something creates a thumbnail, right? And almost like trivial use cases. And I'm like, this stuff is like way easy, like way super easy. I mean, when you get into it, really, we know it's never that easy. And we're going to get into sort of all the things that you really need to be doing when you're doing serverless kind of development and that style of development. But in terms of use cases, right? Like what are some of the cases where you've used serverless and it was a good fit, and perhaps some cases where you said, you know what, maybe having a long-lived service instead was a better approach. What are some examples we can throw out there?
So use cases for me have always been like very small microservices, things that aren't even worth spinning up infrastructure to run. It could be maybe like a 50-line kind of script that does some specific functionality. Also, like I mentioned earlier, the event-driven stuff, things that are dependent on some event happening before it fires off. Another great use case has been as a just general cron replacement. You always have the issue with having highly available cron and having multiple servers with the same schedule and not stomping over each other, and you'd have to implement weird kind of locking mechanisms. But by having serverless functions, you could depend on the higher level kind of timer from the cloud provider, and you could have a single kind of cron source. And for not so good use cases are anywhere that I've had to maintain state or maintain some kind of cache for speed and things like that. Serverless is not conducive to state, as it actually forces you to be very stateless unless you want to go to some network kind of storage. So any of those use cases where long-term state on the app tier is important, serverless hasn't been good for me.
Yeah, Stephen, you mentioned a few times events, and that really these functions run in response to events. What sorts of things are events? What kinds of things that can happen? What sort of examples are we talking about?
So when serverless kind of first started, a lot of the use cases were just pure HTTP request and response style cycles, but then you had these cloud providers kind of plugging in the ability to integrate with their other services. So for example, for Johnny's use case around S3 upload and things like that, now you have events coming directly from S3 to tell you, hey, something has happened in this bucket, and upload has happened and delete has happened. You can now asynchronously take action against it. You have the same thing against any other type of source where it's telling you, it's pushing that kind of event to you, it's pushing that payload to you. Instead of you going out and polling and finding out when things happen, you're getting a payload that's telling you what's happened, and it's in a schema, it's in a shape that you understand from your function, and then you take action against that, and it makes life a lot easier, and it becomes that glue layer like Johnny described, where these services are actively telling you what they're doing, and then you respond to that.
Yeah, if you think about from a cloud provider's perspective, it's almost impossible not to figure out serverless is so fundamentally important because that's the only protocol that you can talk. Like you need to provide some arbitrary execution environment for some events because there's no way you can talk to your cloud provider, but they cannot talk to you. So it's not surprising that it became so fundamentally useful because that's how they talk to you back.
Yeah, so when in the App Engine, basically, especially now in the latest version of App Engine for standard environment, you basically write your Go program as a normal program. It's actually package main, and you use the handlers, you use whatever you're going to do. And then you ship that to App Engine, and then I think it scales to 0, so there's nothing running. And then the first HTTP request spins up the instance. It spins up your program, and in theory, then you can start kind of replying to those requests. So I've tended to use it in that way of really still just a web service that I'm putting up there. And it might be serving a website and associated services, but usually it's all for me been HTTP driven. So a request comes in, we spin up the instance and deal with it. And then that instance at some point will die. And actually, if that's how you think about it, and you have to remember that one instance, requests from one user might go to one instance. The next request from the same user might go to a different instance. So if you imagine this sort of load balanced environment like that, that has quite a big knock-on effect to certain design decisions about what you build, as you mentioned, Stephen, which we can get onto later, yeah. But for me, it's been really useful to be able to build a website or a web service or something and just put it into App Engine and not worry about it, and it sort of just keeps working. If nobody uses it, it's fine. It doesn't cost me anything. I have one, Gopherize Me, which is that service where gophers can create gopherized versions of themselves using Ashley McNamara's artwork. That's an App Engine thing, and that one does actually sometimes it gets quite a lot of activity, and I'll pass over my free quota into having to pay for it.
I think that's a very good point that you made around treating serverless functions like you would web services that you usually write, where you have stateless computes here, where you don't know for sure where requests are going to get routed, and you don't maintain state on disk, right? You always externalize the state because you don't know what you're getting. It's a very good mindset to keep with serverless because that's very much the kind of use case you get. And even when you're not doing something that's directly HTTP, those events kind of come in that same style where you get an event, you get a request, and then you have to do some kind of response. So you have to take some sort of action against it. So it more closely aligns with that use case.
Right. And my uses, one of my favorite uses for using sort of the serverless model is being able to sort of react to things coming off of a queue, right? So I've had projects where because some of the operations didn't need to be synchronous, right? They didn't need basically, it's not like you had a user sitting there clicking something and waiting for something, some sort of response to come back, like the sort of the traditional HTTP model. You could basically trigger something asynchronously, right? Maybe a user performs some action, and then you drop some sort of data onto some sort of payload into a queue, and something somewhere is going to respond to it, right? And so that allowed some teams, really, like a front end team, basically I was responsible for the user interface, the back end that captures these events, and then basically dropping off onto a queue that another team basically was responsible for writing functionality that basically picked up and processed it, right? And then they had that sort of asynchronous model worked very, very well, both in terms of sort of decoupling the concerns, right, between what the front end team needed to do and what the back end team needed to do, but also in terms of sort of showing like a very good example of one of the types of event sources that you can have, right? It provides a lot of different ways that you can trigger business functionality, right? When that goes beyond just the traditional HTTP model, right? But one of the things that we ran into, and there's been other folks who have come out through blog posts and whatnot and sort of noticed the same thing as well. We talk about how sort of the costing model for serverless, be it Lambda or Cloud Functions and whatnot, because you're not paying for idle. I think there's this sort of a misconception that because so much around sort of the marketing, so much of it is focused on, well, you're going to have so much savings, right? Because you don't have something that's sitting there and just waiting for things, whether it's being used or not. You're going to have so much savings, right? That you can just go haywire, go crazy with the serverless functions and whatnot. But one of the things that we quickly realized was that if you are going to sort of adopt the serverless way, which kind of forces you to think a certain way, right? You no longer are dealing in, you're no longer in the lane of monolith, right? Where you have just one big code base where you can see everything happening. If you start going down that pathway, like, well, I have to sort of make my functions very, very small to do one thing and one thing only. And then now you're firing off this one small function that does, that one thing, and you're constantly, right, firing that off. That could end up actually costing you more depending on what it is that you're trying to do. So there was one very good example, blog post I remember that came out a few months ago, where the unit of work that was being fired off, right, one per execution of a Lambda function. I think they're dealing with AWS Lambda. Basically, it ended up costing them more rather than, say, leveraging Go's concurrency primitives, right? Basically using Go routines, for example, whereby in one execution of the Lambda, you could actually have multiple Go routines doing like a work in batch, right? That way you still have one Lambda execution, right? But you're doing a lot more work in there, be it all the work was of the same kind. It's the same type of work that you're doing. So you're not violating that should do one thing work kind of thing. You're just batching the amount of stuff you're doing in one execution. So that ended up costing them a lot more, right? This is one of the things where if you just drink the Kool-Aid, if you just buy it off the shelf just like that, and you basically start making everything, every time you want to use a piece of functionality, you just execute a Lambda, you might find yourself in some hot water, right? So I'm wondering, like, what are some of the gotchas, right, that you yourselves have experienced, like, along those terms?
I personally was thinking that like Lambda is like CGI model, invented, in the century again. It's just that like all the optimizations is just basically like the cold start and like the startup time is actually like really fundamentally important if you are promising some cost advantages. And one of the things that I really like about like Google Cloud Run decided not to go deployment per function. It's more of like this, like you're handing off this server, a long running process, which still has a limited execution environment, and like they can kill the server in 15 minutes or whatever. But at least like you can bundle a bunch of things. So when you're bootstrapping the server for the first time, at a cold start, it actually like can serve like multiple endpoints at least. But then if some of the endpoints are never going to be used, is it in terms of like memory and like CPU usage, is it some extra costs, right? Like there's always this like pros and cons, but I like the fact that like they are giving you the option to bundle things together. So if you believe that like some endpoints, some functions, or let's say some functions are going to be called really frequently, you can bundle them as like one server, and each time you bootstrap, it's just going to be the one bootstrap serving 3-4 endpoints.
Yeah, I think Johnny made a very good point in terms of it's not just a kind of catch-all silver bullet. So I think in the same way that operators would traditionally decide on like instance size they would use and things like that, they have to consider their workload. If your workload is 24/7 throughput, always, by the minute you're doing a lot of throughput, then serverless may not be the right solution, because having a constantly on server, of course, will help with that. And even having like cache and amateurization there, you get to, trade that off. But if you have very kind of spotty workload and you need a good amount of scale and ability to run things in parallel, then yeah, serverless is beneficial, but you need to kind of make sure that you're doing that math and understanding how much throughput you're going to need from a system, and even compare against, just a regular compute instance and see if you could determine what the best approach would be.
Very good point. Very good point. So along those lines, let's talk about sort of the we've been talking about how different cloud providers have slightly different solutions, and there's some commonality across all of them. But you're starting to see some deviations with Cloud Run, for example, from Google. You're starting to see sort of a differentiation there in terms of like what the containerization model is. And correct me if I'm wrong, Jaana. This is your world, so I'm wondering at some point somebody's going to ask themselves, well, okay, every time I have to write a piece of code that is going to run as this serverless function, right? It's going to run somewhere. Is it possible for me to write this in a cloud agnostic way? Is it possible for me to basically not have to import in some sort of third party, whatever the cloud provider's package is, whatever the library is? Is it possible for me to just write my functions in a way that I can run them on AWS Lambda? I can run them on Cloud Functions. I can run them on Azure. Is there any way to have that, right? And I know there's OpenFaaS as well, which is I looked at that project the other day and it looked very promising. So there's all these different options. Is it possible really to write all of your functions, right, in a sort of a cloud agnostic way and have them be deployed without really having different build pipelines in different ways, actually having to import different code libraries from different cloud providers? Like, how easy is it? And is the cost of creating abstractions, right, worth it?
Can I ask a question? I was really skeptical about the portability aspect of, serverless in general, but in the end, what I realized is just like I import a library, whatever, but it's really a small piece, right? Then the function block and whatever, the reusable part is actually, it's just there. You just wrap it with, you just call maybe like 2 lines from a third-party library. So it was not truly a big concern if you especially organize things in a cloud agnostic way, plus doing that like loss glue at the end. Again, like this is my personal opinion, but we are trying to now reinvent all these different abstraction models that make serverless running everywhere, including your on-prem. But like I'm questioning, is it really worth it to have that like abstraction model, or is it just easy to just switch to those 2 lines and like import a new library and you will be good to go? I think also reusability of your functions is one thing, but I think the overall orchestration aspects and the configuration is another thing, which is definitely right now proprietary based, and that's another I think conversation to have. I think it's easy to reuse your handlers, but how can you just spin up the same environment with similar naming and so on, similar scaling properties and configuration on another cloud provider? I think that's more difficult.
I like your question, though, of questioning the premise of this. And it's a little bit like how we get very excited with the idea that we can swap in a different database, when we've built these right abstractions. But why would you do that? And I've especially heard people try and say, like, this is a MySQL database, but because of this abstraction, we could put a Mongo database later if we wanted to just switch it. And it's like, well, they do very different things. So it seems like, I feel like we get excited about the possibility of that without really thinking about whether we're ever going to actually need to do it. And that's the other thing about, you made that point, Jaana. The cloud, these functionless services are kind of meant to be sort of small and lightweight. And so I think if you are going to be moving over to a different provider, it's a good opportunity to do a rewrite of some pieces as well, because that's something we should probably be doing anyway as good practice. But yeah, it's interesting to think of that, I think.
I think as limitations change, as the way that as the limitations change, you need to consider some of that. Again, like ORMs were a thing, but in reality, nobody does that, because each time you're changing your database, you need to almost re-architect, at least your data layer. So, I think it's natural to ask, like, is it really feasible to achieve portability?
I think to those points, though, the handler is rarely the interesting part of the serverless function, right? That's just how the information comes in. But what you're actually doing with the function is the piece that probably ties you to the cloud even more, right? So if you have a handler for S3 events, then you're properly tied to the S3 API. If you have a handler for some kind of Google Cloud Storage event, then you're reaching out and doing these other things with the Google Cloud API. So the handler is probably the easiest part to swap out, but all the other kind of tentacles that are in your code base related to the cloud-specific APIs and things like that you're using to handle the event are the things that are going to be harder to switch out. And I rarely find that kind of multi-cloud argument to be worth it in the end. I remember back in the 2012, 2013s, where everybody was talking about multi-cloud, and it's just a race to the lowest common denominator at that point, because you have to kind of standardize for whatever the lowest common functionality is, and it's never kind of worth it. So having small packages that are easily rewritable to swap out, the vendor, what have you, sounds like a better approach, because the core logic will remain the same. It's just the APIs and how you're getting the data might be different.
This episode is brought to you by Datadog. Datadog is cloud monitoring as a service. See inside any stack, anytime, at any scale, anywhere. So what's new with Datadog? Coming off the heels of Dash 2019, Datadog's annual conference about building and scaling the next generation of applications, infrastructure, and technical teams, we have a lot to cover. Serverless functions. Datadog Serverless View gives you complete visibility into your code running on AWS Lambda. Browser logs. You can now send logs directly to Datadog from web browsers or other JavaScript clients for full stack visibility. Network performance monitoring. This enables you to visualize the flow of network traffic in cloud-based or hybrid environments. Mobile application. Datadog now has a mobile app to make it easier to triage issues when you're on call or on the go. Real user monitoring. This enables you to visualize and analyze the performance of your front-end applications as seen by your users. And a final list of what's new: log rehydration, metrics from logs, Watchdog for infrastructure metrics, metrics without limits, tracing without limits, trace outliers, and so much more. Head to datadog.com/GoTime to learn more and get a free t-shirt. Once again, datadog.com/GoTime.
I think this leads us to the next sort of key topic here, which is how do you sort of in a very practical way, right? If I'm a Go developer, right, or rather, if I'm a developer who happens to be writing some of the functions in Go, right? How do I set up or structure my Go project, right? That way, in a way that allows my business logic, my behavior to be cloud agnostic, yet the entry point where I have to use, say, I have to import some sort of a package from AWS or from Azure or whatnot. Like I personally write my serverless Go projects the exact same way I write every other Go project. And here's what I mean by that. Basically, I try to, in a regular sort of long-lived service, I'll write my main, my package main, function main, my entry point. I keep that as light as possible. Right? I don't have a ton of stuff going on in there. Maybe I'm reading some arguments from the environment. Maybe I'm reading something from configuration or from arguments being passed in, whatever the case may be. I don't do anything different when it comes to that with regards to serverless technologies, right? And pretty much everything else in my business logic, I'm not gonna basically I'm not going to bring in those third-party dependencies, say, S3, for example. I'm not going to bring that into my business logic. I'd rather create some sort of local interface, right, for that behavior, for the functionality that an S3, right, implementation can satisfy. I'd rather, I'm not going to bring in like a DynamoDB, right, package into my business logic. I'm going to write a local interface that whatever the implementation of DynamoDB I'm passing in is going to satisfy. So to me, like I don't do serverless programming any differently than I do any other kind of Go programming. Like I'm by following, which I think is sort of the biggest point that I can seek to put forth here, is that you don't have to, the best practices about Go development don't go away the moment you start doing serverless work. Right? You should strive to abide by those same exact principles and best practices that we talk about for any other kind of Go project. Yeah, Matt.
Yeah, I think that is a great lesson then for anyone that hasn't got much experience with serverless. I think that's actually quite a key point there. What we're saying is that yes, there might be changes in behavior and you might do things differently in your code in the serverless environment, but those things are good things to do anyway for their own sake. So that's quite encouraging because it's possible. And actually with App Engine, until the recent release, you did have to do things slightly differently. And so therefore you were forced to create some abstractions that you might not be happy with and things, or do other changes to your project. They changed that now. So as I say, you just deploy its package main. That's what you're deploying. And there's a few things that fall on from that. So for example, Jaana, you mentioned the cold start thing. So this is where there's no instances running. The first request comes in and it has to do some work to get the instance up and running. And you want that to be quick. You want that to be as quick as possible. So that might mean you would defer some setup for certain handlers until later and things. And I do these sorts of things as well, even though in some environments it might be that I deploy a server once and it's a long running server, so I'm not really getting the benefit. But still, I think it's good practice. And so that's one example. I use the sync once package with handlers, and that allows me to make sure that I only do the setup the first time a request is called and only do it once atomically. So even if you are receiving multiple requests, every request gets its own Go routine. It's possible that you might be trying to do multiple setup on the same thing, but this would avoid that. with sync once. That's just one example.
I definitely agree. And I think serverless to a certain extent is just a deployment detail to the code that you're writing. So even for me, when I'm writing serverless functions, I don't try to do anything Lambda specific or what have you until the very end when it's almost time for me to deploy it, because even locally, I treat my Go file as just a binary that I built. I'm passing in a JSON file from my local file system to mimic the event that's coming in. So I'll do my full testing cycle. I'll do everything that I need to do on my local machine. And then when it comes time for me to get ready to deploy it, I'll swap out that handler that was reading in that file to be one that reads in an event from AWS. But the rest of the workflow is the same. There's nothing specific to serverless that you have to really do in your code base to get it to work. And I feel like maybe people are intimidated by serverless because they hear these terms and they don't really understand what it actually means. But there's nothing really different, like Johnny said, to standard just Go development or any development. It's just about how you're getting that event and how you're processing it.
And I think one of the main reasons why, the cloud providers want to, provide an idiomatic experience in the end of the day, because as you put more barriers in terms of you've got to learn new organizational tricks, tips, whatever, in order to push the serverless. That's kind of against of the serverless model. The main idea is you should care about your business logic. You should be able to use your existing tools and deploy things easily and maintain things easily. One of the things that I've experienced myself is usually I think coding organization-wide tips apply to serverless, but it also depends on, as Stevenson says, serverless is about deployment. So it really changed the way I organize my modules. I would bundle things together if I'm going to deploy them together. In terms of maintaining dependencies, I want to make sure that they are represented by the same module file. Those are the only differences I've experienced myself. Otherwise, I can apply everything else to serverless programs.
Another one is global state. We talked about these things should be stateless, and global state is worth avoiding in Go altogether, I think, in almost every case. Global state, for anyone not sure, it's essentially variables in the package space. So if you do use those, and there's lots of examples in Go where we see that, by the way, and there's plenty of examples throughout the standard library too, but the trade-offs, it can be simpler. It can be simpler, and you just have to write a main function and you've got some variables in global space for tiny little programs or scripts, essentially. That sort of use case, I can see where people would use them. But it really hurts testing. It does a few other things. It introduces other bugs that might be difficult to find and solve. And that's another one that you can extend. So it's not just don't use the local disk because the next instance might not have access to that same disk, but don't use the same memory. Don't use global memory, and don't assume that an instance is going to have that same memory over any length of time. Those kinds of things, again, are just good practice generally too.
Yeah, you definitely shouldn't assume that. And this might get into maybe some advanced topics, but once you fully understand the trade-offs and things like that, there are certain use cases where, because there is a possibility that you're reusing the same container and things like that, that you could maybe optimize for checking if you are in an existing container and things like that, and optimize for that if you do have long startup times or startup times that are going to increase your latency. But that's, like I said, a more advanced topic once you understand what you're dealing with and how these instances may live or die and may come and go.
That's a really interesting point, actually. And I do wonder whether those sorts of optimizations usually involve some kind of complexity in the project, in the code.
Of course.
And of course, they might make sense at one point of time, but then over time, they may stop making sense and things. So that's a very interesting thing that you have to also bear in mind, I think, is then keep checking the architecture that you end up with and make sure it stays relevant and things. Yeah, and don't optimize too early. That's the other thing.
Something that you mentioned that actually bit me in the inverse, you're saying don't do global state and things like that, but just because it's serverless doesn't mean that you got a fresh, clean starting environment. So I had a project where I was pulling files from S3 and I was processing them and never cleaning up because it's serverless and it's just going to get rid of the container. And then I started getting failures after maybe 30 or so runs. And it's because I filled up the disk on the execution environment without thinking that, hey, maybe we're getting reuse if the code is loaded in a hot path and it's continuously using that same execution environment. So cleanup is still important, and unsetting global state, if it is problematic, is still important because you might get that same exact container back and it might be problematic.
That's interesting. And I suppose there's also security implications there too. If you're pulling data from one customer, and then you get the same instance, you've not thought about it. That is a very good point. I'm so pleased you agreed to do this, Stephen. I think you might have just saved my life.
So the other, Stevenson, you mentioned something interesting about testing and how you test. Like, so perhaps this might be a controversial statement on my part, but all of that sort of all the work going on right now and the sort of the testing, the way you do testing with regards to serverless work, honestly, I don't think it's there yet. Like I can't. The experience is still too. It's just too much, right? Like I don't have the confidence, right, to be able to test pretty much the entire setup locally, right? Which is why I very heavily depend on unit testing. I very heavily depend on sort of basically invoking or simulating the invocation with the right JSON payload. And basically, I'm trying to code the way I code any other kind of Go application as much as possible, right? But then there's something to be said for doing some sort of integration level testing. Like at what point do you sort of cross over into saying, let me now assume that I'm going to have some real event, right, coming from some source other than my local development environment, right? At what point do you cross that threshold, and when do you do that sort of integration level testing?
So for me, even the case where you are getting events that are coming from some source, those events are very well defined and adhere to a certain schema, right? So you can maybe test the variability of the different data that you can get back from those events. But like I said, I do straight up like JSON files on my local file system, and I test that I assert that the output is what I expect, or I assert that the event takes place the way that I expect. But I very much come from that kind of hacky sysadmin background where I'm writing bash scripts and I'm testing it right in line, and I'm making sure that the desired output is the true kind of proof that the code works. And for Go, at least, I don't change my testing very much because I'm writing things local, and because I can still run it just as a straight up binary. I'm doing the underscore, test files, and I'm testing the things that I'll normally test doing the function level test. But overall, it's just kind of an integration style test where I just assert that I'm getting back what I expect to get back before I go forward and try to deploy it and see what happens.
Can I ask a question before talking about testing? How do we develop, serverless apps? Given like cloud is a thing and it's just like impossible to emulate, development stack is just becoming so frustratingly complex. I find it so hard to like keep the similar environment in my development environment. I think serverless is just like adding this like yet another big burden because it's just far too abstracted away. The only way that you can emulate it just like basically running the thing in the cloud provider. So what is your strategy when it comes to development?
So I don't believe in like emulating like this full environment because like you said, it is complex. It's multivariate. There's so many things there. So I literally run it in like a test account. I'll reach out to a test S3 bucket. I'll reach out to a test Dynamo table, and I'll do that full exercising because that's the only thing that's truly going to test that code path that you've written for, right? You have to actually reach out to these APIs to find out certain things. And I think that's the right level of testing given the amount of effort that you put into these functions. You're trying to keep them small. You're trying to keep things kind of pretty fast moving, and setting up a full kind of mock environment just to do that seems like overkill in my opinion.
And unit tests are more useful. But the ones that you're describing, Stephen, sound kind of like unit tests. If the serverless function is the unit, and you're passing something in and making sure what you get out is what you expect, that's kind of a unit test. And that is, for me, they're the most useful tests because if something does go wrong, they kind of point like a laser, they point to what went wrong. Usually, ideally, only one test will fail if there's a new bug or something, and then you're drawn straight to it. But I know that Monzo, which is a bank that's written in Go, and everyone should check it out, by the way. I think it's what they're doing is really cool, and not just because it's in Go, but I know that they have in production testing, so kind of like canary testing or whatever, where they will actually simulate real behavior in their production environment. And these tests are just running continuously. And I suppose they'd be capturing metrics and things, and checking to see how the system's performing and all kinds of things at the same time.
Is it they're replicating some of the requests to a testing environment and like just kind of like seen? Is it kind of like a cannery, but before it actually becomes a cannery?
No, but I know that they probably, I mean, I think any mature project probably has a quite a big testing story. But in this particular case, I heard Matt Heath talk about it. It's one of the engineers at Monzo. You can find him online, actually. He speaks about this subject very well. They actually literally simulate real users using their bank cards and transferring money to each other and doing all these things that people really do. They probably do have another environment that they put code in before and run the same set of tests. But yeah, it's probably part of a wider testing strategy for sure.
And talking about testing in production, one thing that I found to be absolutely critical is getting the right logging level and getting the right amount of information out of your function, because you don't have a nice server to SSH into. You don't have all these kind of debugging tools that you would have in a traditional environment. So making sure your code is observable, making sure that you're logging, making sure you're understanding the execution path that your code decided to take is important in debugging and quickly understanding, where things might have gone wrong.
So along those lines, right? So there's two things I want to touch on. So Matt touched on the point that you have a function that is a unit representing some piece of work, some piece of business logic, but there's obviously systems that are built that rely on multiple invocations of multiple different functions, right? There's this orchestration that you need to sort of introduce into the sort of your environment in order to get the right things to happen in the right sequence, right? Any non-trivial, one function sort of thing, whenever you need to sort of have like more than two or three, then you're gonna need some level of orchestration. The current best practice is that you shouldn't have one invoke the other, because of the basically, if you have this chain on down, basically, especially if it's like synchronous invocations, then the first one's kind of waiting for all the other ones to finish, right? And then basically you run the risk of running a timeout, and that basically your request just gets dropped on the floor. So there's lots of gotchas and sort of do's and don'ts over there on that side. But and we're gonna swing back around to my other point, which is really around the sort of the debugging story, which in a serverless highly distributed environment like serverless applications, that requires a lot of extra sort of infrastructure around it, logging, metrics, tracing, all that stuff. We're gonna swing back around to that, but I wanna know how do you handle orchestration of multiple functions when you need to get something done?
So shout out to step functions in AWS. I'm not sure if Google has something equivalent in GCP, but that really opened up a whole new world for me with regards to chaining serverless things together to make one big kind of cohesive unit. Before step functions, it would very much be that use case where you described, Johnny, where you're calling other functions or passing things via a queue or passing things via some other traditional mechanism. But with step functions, you got the ability to have one function input, or the output of one function becomes the input of the next function, and be able to chain it down that way. It's still decoupled, still passing things, but kind of in a way that you could look at the transition between the states and see what the payload was and understand what that next function got, to the point where you can have two completely different functions and they're doing the things that you expect them to do because you're looking at the payload, and you could test one each independently with their own respective payload. And as long as you make sure that the previous function output what you desired, then you're in that good place where you're getting that best of both worlds, where you're getting that kind of synchronous execution from the outside, but internally it's asynchronous and it's decoupled from one another.
It's interesting. Chris James in the Slack channel earlier mentioned the environmental cost, i.e. literally like the green cost of serverless versus just having our own projects and things. That's the first time I've even really considered that. I suppose I assumed that the idea is there's this shared resource, and it's that resource is there doing things. It's ready to do things anyway. And we're in theory all taking a piece of that and then just paying for a little section of it. So it feels like it ought to work from a green perspective, but actually I don't know.
I'm also assuming that AWS, for example, is running a lot of their compute for serverless on their spot fleet, or the fleet of systems that are unused at that time. And it's just an optimization on their part in order to make sure they're getting maximum utilization from the set of services that they already have running. I doubt they're spinning up, brand new servers hardware in order to run these kind of serverless functions. I think they're very much making use of that additional capacity that they have to run those micro VMs on.
Maybe initially that was the case, but I wonder now. I mean, it depends how big AWS is as a business to Amazon, because maybe they are now spinning up compute to sell. I don't know. I've ruined the conversation.
Yeah, I'm not sure. I would have to look into that, but because I know how they do Spot and things like that, it'll be very unlikely that they're not making use of that spare capacity to kind of provision for these micro VMs.
Yeah, well, that's the promise, I think, or one of the promises at least, of just this, the point of sharing this infrastructure.
This episode is brought to you by X-Team, and here's Jason Silva, most known as the host of the TV series Brain Games on the National Geographic Channel. He's talking about how you can become wired for adventure.
Human beings are wired for adventure. We get off, we get activated by novelty, by the thrill of something new. So really, if you want to activate the human spirit, go on an adventure, take the journey, heed the call, so to speak. And the question then becomes, how do we reconcile our desire for adventure to turn our lives into a dynamic, active work project while simultaneously being responsible, while simultaneously paying the bills, while simultaneously feeling like we're making a contribution and we're being productive? Most people will tell us, go to work, go to work, go to work, save money, and then go on a great adventure. But what if there's a solution beyond that? What if wireless technologies, such as what we're seeing increasingly today, can allow us to become tethered while being disconnected, to be close while being afar, to be everywhere at once? And so I recently heard about a company called X-Team, and these guys, let me say it, they really do embody these values. They might as well be the poster children for the rise of digital nomadic tribes, right? People, entrepreneurs, free spirits around the world that are gallivanting, that are exploring, that are truly living the adventure, right? Yet at the same time, they're a community of software developers who are super productive, who are creating amazing software solutions, solving problems, solving with companies, while living a life in which they realize more than ever, access is more important than ownership. So my friends at X-Team, I celebrate you for what you embody. I celebrate you for being brilliant, innovative, counterintuitive software developers stationed around the world and doing your thing and really living up to the ideals of life as a great adventure. 21st century poster children for what's possible for human beings. Free yourself from the constraints, from the traditional, from the tetherings of what used to be, and let go. Take the journey, heed the call. Much love, guys. Cheers.
If you think you're wired for adventure, you want to become wired for adventure, learn more about our friends at X-Team. Head to xteam.com to learn more. Again, xteam.com.
So now we can swing back around to the other topic of debugging serverless applications. Like, I mean, honestly, that was sort of the biggest other sort of revelation to me when I first started doing serverless work, which is basically like, okay, in a traditional monolith, right? Like Stevenson was saying, like if you really had to, right, you could SSH into a box and get all your logging, everything that basically was part of a request. You can get to see it all there, right? Granted, you know, in some places when you SSH into a box, I think you should jettison that box. I think that box should not go back into your fleet, but that's besides the point, right? But that old model of being able to sort of go see everything in one place with serverless, that's gone. That's out the window, right? And one could argue that even in a high scale sort of distributed system, you know, when you have like full long-lived instances, right, you're not guaranteed that the request is going to go to one instance either. So you kind of still have the same problem there. But with the serverless model, we kind of don't have a choice, right? If you need to know, if you have a situation where you're orchestrating multiple serverless bits and pieces, right? You know, something's writing the storage, something from a queue, something's, you know, sending in some communicating with a third-party service, whatever the case may be. If something goes wrong, an end user makes a request, right? Maybe you have an API gateway that fires off a Lambda as a request of this invocation. And then you're touching on 3 or 4 other different things, right? Before some sort of response goes back to the user. If something goes wrong somewhere in there, right? Say the user gets a 500 error or something, right? Where do you start? How do you even reason about this highly distributed environment where nothing is in the same place? None of it is all in the same place. How do you go about that?
So I have so many opinions on this topic, but I can say that I think the we usually start with the networking layer and distributed tracing to sort out what is the specific service the problem is coming from. And I think cloud providers are doing a good job, but not perfect job when it comes to instrumenting things and exposing similar data signals. I think the biggest problem is, as a user, I won't be able to see end to end where is the trace, and like a cloud provider need to contribute a lot to that, because some of the traces will come from storage, some of them will come from like load balancer and so on, and you are kind of like somewhere in between, right? Like sometimes it's just the cloud provider is having an outage, not you. So we had this particular problem that like our customers were calling us, hey, like, your services are down or something. We're having this like difficulty just, keeping this SLA. And we constantly have to like go back and like debug their services. But we realized that like if we consistently output a signal, distributed trace at least, to kind of like represent and navigate the user as the initial thing, as like the initial step, I think that will be the optimal thing. And then I think once you figure out your service, you can just go dig and like look at the other signals like logs and so on. But I think as an industry, we are having baby steps at this point in terms of, diagnosing or at least like navigating the user or the cloud provider to where the problem is coming from.
So what I've also found with regards to like Lambda functions and things like that, typically I'm using my error blocks in Go to make sure that I'm outputting as much detail as possible, as close to the source of the error as possible. But traditional things like correlation logging and things like that, with tracing, making sure if you have multiple serverless functions that are, tied together for a specific workflow, if you have the same correlation ID across that specific workflow, at least you can paint a holistic picture as to what happened throughout that thing. And even for like request response cycles for HTTP, for Lambda functions, for example, you'll have situations where you failed in a way where you can't necessarily provide a response back to the caller. And it's important that you dump out as kind of much detail as possible, because they're going to get a 500, but somewhere under the hood, something went wrong that you could have logged. So instead of just kind of dumping out that function altogether, logging that kind of detail makes it easier to get back to what caused it.
One interesting thing is like, you have to have like some sort of instrumentation already in your function or whatever. And it's just like hard for people to determine what to instrument. I think we are doing not enough work in terms of like, maybe investing in like postmortem debugging and that type of stuff. So you can just like at a later time go and like put a breakpoint, just get a snapshot of the, existing instance and like take a look at some of the variables or, something like that. But yeah, I think we're baby stepping, like absolutely no way to navigate to the problem. Absolutely, no easy way to correlate with other signals. And it's an organizational problem also. I work with when I was working on the instrumentation team at Google, it was we had to like collaborate with all these 50 different products. And everybody has a different, mindset about what instrumentation should be and how it should be. And there are very few standards in this area, which is also not really nice, because Google is doing its own thing, and then you're, just going to another cloud provider. AWS is doing their own thing. We don't really, can participate in each other's traces, or we cannot correlate. And from a user perspective, this is terrible.
So even though there are not any standard approaches, would you say doing common things like correlation logging, for example, like if we go to the most fundamental level, right, you end up with a log somewhere, whether that's CloudWatch logs, whether you end up in Sumo or whatever provider you use, there's some kind of fundamental things that people can do, even if they have to kind of roll their own solution in order to trace back and understand what happened with their execution.
Yeah, when I mean standards, I just specifically mean just the trace ID standard, which is actually happening right now. So maybe in a couple of years, we will be able to understand each other's trace ID. And so fundamental because you correlate everything with a trace ID. So at least we're doing that.
Yeah, that'll be great when that happens, when it's all unified.
Yeah. It's just like distributed tracing is such an organically grown tool, I think. There was no discussion between providers for a long time. And then all of a sudden people realize that like it's actually against distributed tracing not to have a standard, because we are trying to compete with each other, and we can't really go to the infrastructure teams or like cloud providers to go and like implement this propagation format. So the lack of consensus is actually against the fact that distributed tracing is not becoming a mainstream tool. So everybody got together 2 years ago almost to draft a proposal. And the proposal is now becoming more mature. It's going to be more of a standard under W3C. Yeah, so it's going to be a first-class header that everybody recognizes. And it's going to be super nice because you can just go to MySQL and like, hey, just, honor this header or something in some way. You can basically, just go to any infrastructure tool and ask them to do something about it, right? At least pass it so the trace is not, broken.
That sounds really awesome. Is there anywhere we could read about more about that kind of thing? Is there a proposal that's currently circulating?
Yeah, there's a repo. I can maybe share the repo at a later.
Would you be by chance talking about the open telemetry
stuff? I can talk about that as well. This is a different initiative. So open telemetry is more of like an instrumentation library project. So this standard is a wire, like a header, format standard. It's under github.com/w3c/trace-context. And you can read the proposal, and like there's already discussion and like some implementations for some languages. That's going to be the overall standard in a couple of years.
Very cool. That would be huge.
And like pretty much every distributed tracing vendor, including cloud providers like AWS and Google, is actually contributing.
That's huge. Yeah, awesome. So we've been talking about sort of the technical pros and cons, some of the challenges, some of the things that sort of you need to sort of watch out for. I feel like we've been more sort of telling a cautionary tale than anything else. I mean, I think we all agree on the panel here that serverless, or yeah, I'll use that term because there's I can't think of a better term. It's a marketing term, but I can't think of a better one to encompass all the things that make up serverless. But we know in general that it's a good thing. It gives more options, right? More ways to sort of build the right abstraction into your infrastructure, into your world, right? Whatever business problems you're solving. But from an opportunity standpoint, right, for Go developers, like what is the draw? Why should I invest time, right, in learning how to do serverless? Perhaps you work somewhere where the only provider you're allowed to use is a GCP. Maybe it's only AWS. Or why should you spend time learning any one vendor's, or even if you want to go cross vendor, right? Why would you want to invest time, right, and effort into learning the right way to do serverless? Because it's not just about the syntax, not just about the code. It requires a different way of thinking. It requires you to learn a bit more, right, about building these kinds of distributed systems. Why, as a Go developer, would I want to invest this time?
So I think a lot of modern developers end up doing a lot more glue work and stitching work than like just straight up development, because traditionally there were systems that you would have to write yourself, but because they're being abstracted and they're being written for you and they become provider kind of driven, you're doing more stitching work nowadays. You're doing more glue work, and running infrastructure just to do glue work kind of is demoralizing, and you kind of have to maintain these things. But I really found that's the sweet spot for me with serverless, being able to write all these integrations, write all this glue work, but have that infrastructure also be that thing that's abstracted away so that these systems flow as if it's a pure vendor solution without having to, run your own underlying hardware, your own underlying instances and things like that. So I really think that's what makes it worth it. And I think you think about your own workload, you'll find that you're writing a lot of glue layers for things, integration layers and glue layers. So I think that's definitely a good reason to learn it. But also, I think it helps you practice just stateless kind of programming and making sure you're kind of building these kind of distributed applications without having to purely get down into the nitty gritty of building distributed systems and things like that. So it's a good, I think, entry point to understanding how these things kind of start working together to form wider systems that are achieving a common goal.
Yeah, so I echo that. For me, it's about, if I have to write that glue, I don't really know if I'm doing it the right way. It's an extra kind of discipline or something. Like I could make some silly mistakes and that would kind of cost me a lot of time or something else later. So I feel like serverless is a kind of an empowering thing for a developer so that you can focus on the bit that makes what you're doing special and leave the plumbing to somebody else. That's why I like it. It feels like I'm empowered and I don't need to go and seek out help just to do things that are really secondary to what I'm actually trying to do or what I'm focused on.
Yeah, for me, it's more about productivity, right? Like it's a limited maybe environment, but if it matches what I need, And why would I even have to care about like all the, lower level infrastructure? I would just push things and pay as I go. I think that's what the promise behind cloud was initially. So I would start there. And if I need less limitations, then I can always fall back to the lower levels. And for me, a good starting point is just, having a more opinionated, maybe more limited environment, and then like go, just delegate in some of the work to my cloud provider, and then go beyond that and like going to the lower levels if I need to.
Agreed. And I think in the channel, I think let me see if I get I don't want to mispronounce his name. NT Kupila. He mentioned that in the GoTime channel on Slack, that basically learning how to do serverless is actually a good way to actually learn how to build non-serverless systems better as well. And I think I totally agree with that, because I've noticed a certain level of concerns that I've started to have since I've begun sort of doing serverless work that I traditionally didn't have. Things like, this thing, if I can make this stateless, right, then I have less issues with, I don't have to have sticky sessions. I don't have to have, there's a lot of different things, a lot of different concerns that things I used to take for granted, right? Back in the monolith kind of days, the deployment model, that now I'm more concerned about. I'm sort of making deliberate decisions about whether to have this or not have that. And again, with the, with microservices, I guess you can go serverless and nano services. We didn't get into that buzzword too, but that affects really how you sort of approach building these sort of backend systems. Really, for me, that's the big sort of takeaway here, is like you learn to solve these problems, not really worrying too much about which vendor is going to run, as long as you solve the problem from a business standpoint, and let the sort of deployment model, whichever vendor you use, let that be sort of perhaps not the very last concern, but don't let basically a vendor provide the box in which you can sort of build these things, right? You develop your wares, and then you worry about, okay, how do I deploy this thing that actually already accomplishes the business functionality that I need? Now, how do I deploy it in these other things? So, anything else we want to add to that before we wrap this up? I think we've gotten deep in some areas and shed some light on some others.
I wanted to just shout out one more gotcha with serverless in general. The massive parallelism that you get from serverless can also be something that you get caught up with. So, for example, Lambda could scale out, I think, to 1,000 executions at the same time, and your poor database is on the back end trying to handle those requests, and you max out your connection. So, be mindful. Traditionally, you would have connection pools and things like that where you limit those things, but now, because you're in this kind of multi-parallel execution environment, you may have 1,000 connections all of a sudden stampeding against your database. So, just understand those concurrency models and things like that, and make sure that you're accounting for them when you're reaching out to your resources in your environment, because they could come back and bite you.
Awesome. Well, this has been a very enlightening show. I've learned some things, and I've been doing serverless for a little while, so I hope this was great for you, the listener. A big thank you to Jaana for coming back, and we miss you, Jaana. We're glad to have you back on the show. Matt, Mr. Matt Ryer, I borrowed your accent a little bit. I'm not sure if you noticed, but I'm trying to sound, as cool as you.
It was actually the only bit of yours I could understand.
Nice. And a big thank you to our special guest today, Stevenson Jean-Pierre, my fellow Haitian-born.
Thank you for having me.
All right, it's been great. And for those of you who are listening live, hopefully this was useful to you as well. And we love the participation in the Slack channel. Keep it coming. But yeah, if you have show ideas as well, you can absolutely go on the Slack channel, GoTime FM, and recommend some shows, and we'll take it on and do our best with that. But with that, and also thank you to behind the scenes. You haven't heard much from him, but John Calhoun has been sort of doing some of the technical work to make sure this podcast gets recorded properly and everybody sounds good. So thank you, John.
The reason we haven't heard from him, by the way, is because he says, I don't know anything about serverless. All I do is use DigitalOcean and Google Cloud Platform and things. He really doesn't know about it because he's been doing it and didn't realize.
Right.
That's the point.
Right. Awesome. Well, thank you so much for listening, and we'll catch you on the next GoTime.
All right, thank you for tuning into this week's episode of GoTime. If you're not yet, hang with us and go for Slack. We have a channel called GoTime FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.